Welcome! You're watching Certification Preparation Professional Machine Learning Engineer. You can ask questions at any time by submitting them in the box below this screen. We have Googlers on standby to answer them. So let's get started. Certification Preparation Professional Machine Learning Engineer. My name is Magda, and I'm the Global Lead here at Google Cloud for the Certification Go-to-Market team. Joining me today is Lag, Head of Data Analytics and AI Solutions. Welcome, Lag.
Hello.
And Dee, VP of Data Science. Welcome, Dee.
Hi, thanks for having me.
Let's take a look at our agenda today. First, we'll talk about certification benefits. Then, we'll cover certification learning journey. We'll then talk about the machine learning engineer exam. Then we'll talk about certification success stories, as well as we'll review some sample questions. And we'll wrap up with some next steps. Let's start with reviewing certification benefits. We are really happy to track impact of the certification program on our certification community, and we are delighted to report the results of such surveys. So 78% of the certified community members participating in the survey feel more confident in their professional future. 82% can prove cloud skill competency to recruiters. 83% feel that their resume is more attractive. 85% feel more confident in cloud skills. What are some of the benefits of becoming Google Cloud certified? First, you can distinguish yourself with a Google Cloud certified badge and a certificate. You can showcase your certification badge on LinkedIn, your resume, email signature, and much more. You can network and exchange ideas in the Google Cloud certified community. You receive special recognition at select events, and you receive exciting swag for our professional level certifications. Let's take a look at the benefits of certification according to IT decision makers. I think the first interesting data point is that in the last 12 months, pretty much 2/3 of the training budgets were dedicated towards the goal of certification or recertification. When it comes to the certification value, 93% of the IT decision makers agree that certified employees provide added value above and beyond the cost of certification. And then finally, 63% of the IT decision makers say that the economic benefit of certified employees exceeds $10,000 a year. Now, let's review the certification journey resources. By joining today's webinar, you are at the start of a journey to help you prepare for the Google Cloud Professional Machine Learning Engineer Certification exam. To continue, sign up for the Professional Machine Learning Engineer Certification learning journey after this webinar, and you'll receive an email with a PDF outlining some recommended learning to help you prepare for the Professional Machine Learning Engineer over the next 6 weeks. To help you on your way, we'll give you 2 training offers. First, for a free month on Quick Labs to earn relevant Google Cloud skill badges which demonstrate your cloud competence. And second, for new learners to Coursera, a 1-month free offer for the Machine Learning Engineer Learning Path, which includes promotion to complete the Machine Learning with TensorFlow specialization and earn a certificate. As part of your certification journey, you will receive a recommended learning path and relevant training offers. The learning path is a combination of on-demand learning on Coursera and self-paced labs on Quick Labs, where you can now earn new Google Cloud skill badges by completing recommended quests as you prepare for certification. And we're excited to have launched new Google Cloud skill badges, which we recommend as part of your learning as you prepare for the Professional Machine Learning Engineer exam. A skill badge is a digital badge issued by Google Cloud in recognition of an individual's cloud competency. A skill badge is earned by completing a series of hands-on labs and taking a final assessment challenge lab to test a learner's skills through the Quick Labs learning platform. Now, let's talk a little bit more about the machine learning engineer exam. First, let's take a look at our overall certification portfolio. You see the professional machine learning engineer exam is the latest addition to this portfolio. For all of the exams, we strongly recommend practical hands-on experience in the industry to be successful with the exams. Let's take a look at the professional machine learning engineer role. A professional machine learning engineer designs, builds, and productionizes machine learning models to solve business challenges using Google Cloud technologies and knowledge of proven machine learning models and techniques. The machine learning engineer is proficient in all aspects of model architecture, data pipeline interaction, and metrics interpretation, and needs familiarity with application development, infrastructure management, data engineering, and security. So you may be curious, what are some of the core domains that the exam covers? All of this is available on the external exam page and specifically in the exam guide. So the professional machine learning engineer exam assesses your ability to frame machine learning problems, architect machine learning solutions, prepare and process data, automate and orchestrate machine learning pipelines, monitor, optimize, and maintain machine learning solutions, and develop machine learning models. A little bit more about the exam. It is 2 hours long. It's multiple choice and multiple select. There are no prerequisites. However, we strongly recommend at least 6 months hands-on experience with Google Cloud products and solutions. And now a bit more about the exam delivery method. You can take this exam in a dedicated testing centers or take it in the online proctored version meeting the testing requirements. The requirements are available under this FAQ link for both options, whether you're taking the exam in person in a testing centers or remotely. I strongly encourage to book your exam in advance to assure there is availability. And now I'm delighted to have a conversation with our guests, Lak and Dee, and hear their success stories and have the Ask the Expert section with them. Welcome, Lak.
Thank you.
And welcome, Dee.
Hi.
So first, if you could tell us a bit about your daily role and what are some types of technical projects you are working on, starting with you, Lak.
Oh, hi. Yes, I lead analytics and AI solutions at Google Cloud. And these days, I think that I watch other people do more cool ML projects than I get to do myself. But a recent project that I was involved in was like at Google, we have these things that are called 20% projects. And one of my 20% projects is working uh, with weather model data to basically look at how to carry out image semantic search. And as usual, that involved building a data pipeline, being able to read in weather model inputs, and then creating an autoencoder to create an embedding of these weather images, and then using those to perform image search. And that was fun. It was fun to basically get my hands dirty. But in my usual regular job, I work with other businesses that are trying to solve their ML challenges, and we essentially go ahead and we build reference architectures, sample code. We help them get going on their journey in terms of everything from building a data warehouse and bringing in the data to building custom machine learning models or using pre-built models from Google Cloud, like, for example, the Document AI form parser to digitize data and then use the output of those as inputs to further downstream ML models.
Thank you so much for this introduction, Lak. And how about you, Dee? Tell us about your role and some of the projects you are working on.
Of course. So I'm the VP of Data Science at Jellyfish. So we're a digital marketing company that provides data, digital media, and training expertise for our clients. Same as Lac, I used to doing a lot more hands-on data science challenges myself. But now in my current role, I'm mostly overseeing the execution and delivery of advanced analytics and data science project. So there's two focuses in my team. Currently, we're focused on the AI innovation prototype type of development projects. And we're also helping our client to do more of a cloud for marketing initiatives. So just some examples, project that we're currently working on. We created a creative analysis tool that used to analyze the creative banners in our display and the video ads to analyze what works and what's not with the GCP vision APIs and the video intelligence API. And another example would be working with predictive models for our clients, such as building a propensity model to predict the likelihood of a website user to make a purchase action, where we then use the model output to activate the insights by creating high value audiences for marketing campaigns and create more personalized website.
Thank you so much, Dee. Dee, could you tell us a bit about your exam preparation experience?
Sure. So kind of like from my general experiences, I tend to make a lot of plans before taking any exams, especially in this one, as it's a new exam and there's not many like dedicated courses or materials just to cover this certification. So I think it's extremely important to kind of like go kind of out, do a little bit, prepare yourself type of style. So what I did is that I pretty much used the certification guide to make a study plan, and also like trying really to follow through with the plan and stick with the timeline to making sure that I was able to accomplish and I'd be able to definitely take the exam at a certain given time. So what I did was also like kind of chunk up each topics into a different weeks. So for example, maybe like in one of the week when I was preparing for machine learning solution architecture, I would try to do more deep dive into the topic and try to find more relevant courses and materials out there. So one of the things that I find maybe many people are a little bit overlooked is actually looking at the GCP documentation, which I find it's a really good resources to learn all the relevant topics about GCP technologies. And another area I think kind of pretty important for this type of exam is not just to memorize the concepts, but try to like ask a lot of whys and hows, because there would be a lot of scenario questions. So it's really important to understand the deeper concept. So the exam recommend for more than 6 months of experiences. But if you are just like at the beginning of your journey of taking the machine learning engineer exam, I would say like go practice and maybe sign up for a GCP account. So in that way, that can get you to have like a deeper understanding of the topics.
Excellent. Thank you so much for this overview and sharing your experience. Like any other preparation resources that you would recommend to our audience?
Yes, absolutely. I think as Dee said, looking at the documentation and getting actual hands-on experience is by far the best preparation. But in terms of getting hands-on experience, sometimes it can be hard to say what is a good problem that I can solve, and this is where Quick Labs comes in extremely handy. And you could go into the Quick Labs website, look at the catalog, and there is a lot of labs that go into many of the areas that are there in the exam guide, right? So when you look at what topics are being covered, and you might see, okay, I need to know how to do ML pipelines. Look in the Quick Labs catalog, and there will be labs that show you and guide you along the way to building an ML pipeline. While you're doing that, of course, don't just follow the instructions, but instead think carefully about why you're doing each step as you're doing them. But the labs are, in my view, a great resource. There are also courses on Coursera or Pluralsight, etc., that that again provide that bit of more guidance towards learning the topic. But please don't stop with learning the topic. You have to have the hands-on experience that Dee was talking about. It's the hands-on experience that's going to make you successful.
Excellent. Thank you so much. So, how would you encourage someone new to the machine learning engineering field to set a goal of achieving a certification, Lak?
For someone that's new to the machine learning field, what I would suggest, and I'm going to assume that this person already has development experience, right? So this person already knows how to write programs, how to create software, etc. So as far as machine learning is concerned, you want to basically develop your data handling skills, and you want to develop your knowledge of machine learning, and then you want to basically apply them. So those are the three steps. So first step is that I would learn quite a bit about how to create a data science project and follow it through from end to end. In other words, from doing a data ingestion to doing your data pre-processing, carrying out feature engineering, creating an ML model, putting that ML model into deployment. You want to know how to do each of these steps and all of the best practices in each of these steps and gain hands-on experience with them. And oh, by the way, I always forget that one of the great ways to look at an end-to-end project is a book that is called Data Science in the Google Cloud Platform. I wrote the book, so I'm a little biased, but it also helps you in this journey of how to basically know all of the things that are required in order to build a successful ML model put into production. Doing that is an excellent way to learn the practical skills involved. And having done that, as a new person, again, can't emphasize this enough. Don't stop with just doing the labs or reading a book, but take a project, any project, and do it yourself. You will learn a lot by doing it from scratch and doing it yourself.
Wonderful, really great tips. How about you, Dee? How would you motivate somebody new to the field to set a goal of a certification?
Yeah, so I think as a machine learning engineer, if you are just like started as just starting to become one on the journey, I think there may be like two parts. The first part is be really good at machine learning concepts. And taking exam is really a good first step to be able to force yourself to learn a lot of new concepts and get familiarized with a lot of cool technologies. And in the process, kind of like what Lak said, that you can do a lot of labs and play with the new data and projects to gain those experience. And I think as the longer that you're staying in this field, trying to do more deep dive and try to understand more about the machine learning core concepts, understand the algorithm itself would go a long way for your future career. And the other part, I think, is pretty crucial for machine learning engineer career is actually the engineer part. So be able to implement and deliver a production-ready machine learning system is really important. For a lot of data scientists, that communication and business acumen is very, very important to kind of like understand the client needs and be able to do like daily interactions with the client, to be able to understand the business problem and to like extract the mathematical problem. The other part is quite important, is also like the engineer fundamentals and be able to make the proper design choices. And that is could be part from reading, from learning, and also from like experience, just like building the project and really kind of have that problem solving frame of mind is really crucial. And in Jellyfish, I think especially in our team, good at prototyping is also pretty important in terms of, we have a lot of innovative ideas and how to effectively managing the process from the ideation to execution and be able to quickly build a prototype to establish initial value for the business is really important.
Thank you. And the final question for you, what was the most rewarding outcome of preparing and achieving this certification?
For me personally, because I'm a VP of data science, so we do a lot of data science projects. But most oftentimes when we're building a project for our client, we have to working hands in hands with our engineer team. So be able to gain more deeper understanding and insights of those engineering elements, I think it's really important for me. So I learned a lot of good engineer considerations and best practices. Those concepts related with using TensorFlow functionalities for data preprocessing and also like Kubeflow in order to deploy, scale, and manage complex machine learning system is really rewarding for me.
Excellent, thank you. And any final thoughts or some top tips to successfully pass this exam?
Right. Final thought, and again, I loved what Dee talked about, building a business acumen and understanding how to translate a business problem into a machine learning one. That is incredibly useful, as is knowing the art of the possible, knowing like what kinds of problems can be solved well using machine learning and what things are going to be hard is important skill to have. And in terms of tips for the exam, again, I wish everyone a lot of luck. And as Dee said, you will learn a lot in just the process of preparing for the exam, because I know that this exam is extremely broad in terms of the number of topics that it covers. So in many ways, it's a great learning opportunity. And what I find is that the people who are successful in the exam are the ones who go in with this idea of there's going to be stuff that's going to be on this exam that I have to learn, and approach it as a learning opportunity rather than as an opportunity to prove yourself. So don't look at the exam as a way to prove yourself. Look at preparation for the exam as a way to round out your knowledge, and you will be successful.
Thank you. So we are concluding our little interview part. However, our experts are here still with us to review some of the sample questions. So we'll get started with the first one. Is this one for you, Lak?
Yeah, I can do this. So the question is, so you need to write a generic test to verify whether your deep neural network models automatically released by your team have a sufficient number of parameters to learn the task for which they were built. So the idea is that you want to figure out if you have enough parameters, if you have enough layers in your deep neural network model. So how do you do it? So let's look at the answers. First one, train the model for a few iterations and check for NaN values. So this is definitely something that you want to do whenever you train a neural network model. But the reason that you're checking for NaN values is that very often NaN values are associated with bad input data. So this does not really tell you whether your model is any good. The NaN values are often an indication that there is corrupt input data in your pipeline. So that's not the answer. A is not the answer. Train the model for a few iterations and verify that the loss is constant. Well, when would the loss be constant? The loss would be constant when the model has converged. So what you're learning here is that the model is good, but you don't know if it is sufficient. In other words, you don't know if you could learn it perfectly, right? If you could go, whether you need to add more parameters or not. All you know is that you have a model that converges. That's not enough. This is a reasonable answer, but there's something bad about it. Let's keep B as maybe the answer that we'll go with if nothing else suits. But I'm not very happy with the answer B. C, train a simple linear model and determine if the DNN model outperforms it. So this is one way to basically figure out the complexity of your model, right? So typically you train your model until your model starts to overfit. But that's a hyperparameter tuning approach. And this doesn't again tell you if you have a sufficient number of parameters, right? It doesn't know if your search space for your hyperparameter tuning is good enough. So this is not it. So what's the fourth answer? Train the model with no regularization and verify that the loss function is close to zero. Bingo. This is it, right? So what you're doing is that you now have a model and you're basically overfitting the model to the maximum extent possible. And you're seeing if the loss function goes to zero. The idea is that if the loss function without any regularization goes to zero, then it means that you have sufficient parameters to completely learn whatever your input data has. So this is actually a design pattern that is called useful overfitting. And yes, so D is the correct answer for this question.
Excellent. Let's review the next one.
You work for a large retailer and you want to use machine learning to forecast sales, leveraging 10 years of historical sales data. So you have 10 years of data, long data, okay? This historical data is stored in cloud storage in Avro format, so a big data format that is columnar, okay? You want to rapidly experiment with all the available data, great. And how should you build and train your model for the sales forecast? Okay. Number one, load data into BigQuery and use the ARIMA model type on BigQuery ML. So the data is in Avro format. You can load it into BigQuery. That is very easy. And there's an ARIMA model type in BigQuery ML. So that's like a couple of lines of SQL. So this should allow us to rapidly experiment and BigQuery will scale. So we can use all the available data. So this definitely works. But before we just say, okay, A is the correct answer and we move on, let's see if there's a better answer. So A works, right? And that's something that I think you will see quite a bit because these are practical considerations. Sometimes you will have a good answer and you have a better answer. So let's just make sure that there is not a better answer. So B, convert the data into CSV format and create a regression model on AutoML tables. So first of all, taking your Avro file, converting it to CSV, that's going to take a lot of time. And then, yeah, creating a regression model on AutoML tables is actually a better model typically than BigQuery ML. So this is a way to get higher accuracy, but the question asks for rapid experimentation, right? So if the focus is not on accuracy, but on speed of development, B is not such a good answer. If the question had been, how do you create the best possible model, then B would be a good answer, but A is still a better answer because you want to rapidly experiment. So C, convert the data into TF records and create a recurrent neural net on AI platform notebooks. Again, this is what you would do if you had a boatload of data, really large amounts of data, right? And assuming, let's say you have 10 years of historical data, it is hourly, it is by store, you have tremendous amount of data, RNN models will work really well. But this is, again, something that's going to take quite a bit of time. This is not the rapid experimentation that the question is asking about. So C is a great answer, a great thing to do, but not something that you will do if you want to rapidly experiment. Okay, so let's look at D. Convert and refactor the data into CSV format and use the built-in XGBoost algorithm on AI platforms training. Yeah, this one they're just toying with us, right? You're not going to use an XGBoost algorithm for doing time series forecasting. It's not a great machine learning model, and converting and refactoring the CSV format, building a data pipeline every time you want to do experimentation, not a great answer. So D is just like, it doesn't work. So yeah, A is a good answer, and it is the best of the other answers. And as you can see, B and C are definitely things that you should do, you could do, but their goals are different, right? The goal of B would be to create the most accurate model possible. Goal of C would be to use as much of the historical sales data as possible. So to do more data, but with A, you get to create a a pretty good model using all of the data very fast. And so A is the one that basically addresses all of the constraints that are placed in the question.
Thank you, Lak. How about you, D? Some questions for you.
Of course. Cool. So one of the question is that you're a machine learning engineer at a media company, and you need to build a machine learning model to analyze the video content frame by frame, identify objects, and alert users if there is inappropriate content. Which Google Cloud product would you use to build this product? And this is a very practical question, and in matter of fact, we also built something very similar to what this question outlined. So let's take a look at what the question is asking. So there's maybe two areas to consider. One is to test the knowledge of develop a machine learning pipeline. So you got to consider the data ingestion, the problem framing, and be able to understand what are the output and actions to take. And another one is to really test your knowledge of GCP product. So if you look at the answers, the first one is a PubSub, and I think it's a very robust streaming analytic pipeline for real-time data ingestion. So there's no question about that. And then you look at what are the problem that you're trying to solve. So in the question, there's a two thing. One is to identify the objects, and another one is to identify if there's any inappropriate content. So what we look at in the answer, there are Google Cloud Vision API, there's a Video Intelligence API, and also AutoML Video Intelligence. So because here that we're analyzing the video content, and the Google Cloud Vision API is looking at the static image, which wouldn't be a best fit for this solution. Then we look at the Video Intelligence API and AutoML. So the differences of the two is that the Video Intelligence API outputs a predefined label, while the AutoML Video Intelligence output the custom label. However, in this question, we didn't really know, like, is it object going to be like customed or specific object that they want you to identify, but we can put that in a little bit. And also, like, they want to detect the inappropriate content, and what we can see is that the Video Intelligence API also help to identify those explicit content. So overall, if there's no like predefined objects and the content is kind of like identification, the pre-built model is the most effective way, and it's very cost efficient to be able to create a baseline product, and very, very helpful to help fast prototyping. So I think at this point, my answer would be C. But let's look at other options in C. Is that there's a cloud function. Why cloud function is here is that just with Video Intelligence API, you wouldn't be able to do anything. The operations are disconnected. So with a Google Cloud function, that allows you to develop a very lightweight compute solution, and allows you to write very like a simple single purpose functions to be able to create a output from the Video Intelligence API. And in terms of the Google Cloud logging, it is also response to the question that they want to be able to detect, then alert users of any inappropriate content. Because cloud logging also integrate with cloud monitoring to be able to set alerts on those log events, which is essentially the output from the Video Intelligence API. So I think the best answer is the answer is C.
Thank you. And the final question.
So the last question is that you need to build an object detect model for a small startup company to identify if and where the company's logo appears in the image. you were given a large repository of images, some with logos, some without. These images are not yet labeled. So you need to label these pictures and then train and deploy the model. What should you do? So 2 questions. One is basically asking what's the data labeling process for this challenge. And another one is asking about the model training and deployment, which implies of what type of models that you should be using for this situation, and what the serving environment should be. So, so I think like when we approach to this type of questions, always good to keep in mind that always choose the option that meet the requirement, but also provides the most efficient and cost-effective way, considering both platform costs and staff costs. So, for example, maybe there could be like already a cloud solution that charges a certain amount platform fee. That may sometimes outweigh the option to build a complex models that require hundreds of hours of dev time. So in here, that one of the Q in the question is a large repository of images, which means that manual labeling of the images could be very expensive. So, if you look at the answers, there's 3 different approaches. The first one is using the Google Cloud's data labeling service to label your data. The second one is using the Vision API to detect and identify the logos in the image. So the second question, I do have some issue with it because the Vision API, as you know, it's to provide a pre-trained label. And because in this question, it asks for a startup company. So it's more likely that the logo of the company may not be contained in the pre-trained label already. So that is probably not a good suit for this solution. If you look at the questions C and D, it says create 2 folders. So basically one folder uses to store that logo appears and another stores image that doesn't, and then manually place the images in each folder. And as we talked about earlier, that there's a large repository of images, so it's going to be takes a long time, and it's going to be very expensive to do the manual labeling process. So that leaves us to the option A, which is using the Google Cloud's data labeling service. So as you know, the AI platform data labeling service is use a human labeler to be able to identify the labels with a pretty high accuracy, and it tackles both classification and the bounding box issues as highlighted in this question. So I think that would be a great solution for this question. And once we have the label data from the data labeling service, then we can use AutoML object detection to create your customized logo detection. So the first answer is the best. So option A.
Wonderful. Thank you both so much again for your time, your expertise, reviewing the questions.
Thank you. And thank you very much, Magda, for running this event. It was great to meet you. And for all of you watching, best of luck, and hope you get certified soon. Thank you.
And thank you, Magda and Dalak, for having me here. And really great to meet all of you. And for everyone, good luck with your machine learning and engineer journey. And see you next time.
And we are wrapping up here with the next steps on your certification journey. So are you ready to start your certification journey? Go to g.co/cloud/certify and select the Professional Machine Learning Engineer track. We will email you a 6-week recommended learning path and relevant training promotions and resources to help you get ready for certification. You can schedule to take your certification exam when a testing center near you is available, or you can take it online from the convenience of your own home. Thank you so much for tuning in today. Please visit cloudonair.withgoogle.com for more hands-on learning, training, and demos from Google Cloud experts. And see you next time.